What's up? Here we go. Part 2, Section 2, Chapter 7. How do you simplify radical expressions? We're going to extend this a little bit more, do some two different kind of properties that you'll need to write into your notes. And as a review, remember we talked about this last time, which was the old foldable flappy that we made. All the different properties. They apply to regular expressions, algebraic expressions. And as you noticed over the past couple days and the past couple videos, they have applied to the rational exponents as well. So whether you add the exponents, or you multiply the exponents, or you distribute the exponents, or you subtract the exponents, or you take a negative exponent and put it underneath in the denominator, all that stuff still applies. Here's two new ones. This called the quotient property. You need to make sure you write it down. And what it says is this. If you have the quotient, meaning division, of a radical over another radical. And notice this is extremely key. I hope you write this down and make a big old star next to it. These roots are exactly the same. If the roots aren't the same, this rule doesn't apply. And notice the bases here are different. That's another thing. So not only are the roots different, or the roots the same, but another interesting thing is that the bases are different. So what it says, you can actually then rewrite that expression, so it's equal to the nth root, so it's the same exact root. So if this is the third root and this is the third root, great, that becomes the third root. But you can make then the a and the b underneath the same exact radical. So that is nice because you can go back one way or the other to kind of help you simplify and then ultimately maybe evaluate a radical expression. So let me show you an example or two. I'll pull this one up here so you can see it. Whoa. So let's take this one here. I'll make it a little bigger. So great. So I have the square root of 20 divided by the square root of 5. What is the deal? Well, according to this quotient property, I can take these particular things and I can rewrite them as the following. Since it's a square root and a square root, they're both the same roots, I can make it a bigger square root, and I can take 20 and put that there as the numerator, and then I can take 5 and put that there as the denominator. And you might be saying, Mr. Motter, who cares? Why do I do this? Well, I see a fraction right here, 20 over 5, 25ths, that I can reduce, and you should as well. So I can reduce this fraction and this fraction, or I can reduce the fraction into the following. So it's the square root of 4 over 1. That's pretty cool. Now you can actually do this because 4 over 1, you guys know is 4. So it's the same thing as the square root of 4. Wait a minute. Let's keep on going. The square root of 4 is the same thing as just 2. So that, ladies and gentlemen, would be your answer for this original question when it said to simplify. You would break it up using the quotient property. Make it, not break it up, sorry. You would make it all over the square root. And then you would just keep on simplifying and make it down to the square root of 4 to make it 2. That's pretty cool. Let me erase that. And let me give you another example. So I'll pull this one out of the way, and I'll bring this one in. Now check this one out. Now it's the other way, I guess. We have now the square root of that entire fraction. Well, I can apply this rule and go the other way. So I can take this whole thing that's square rooted and break it up into two individual smaller square roots. So I can go the square root of 1 over the square root of 25. Why would I want to do this? Well, it depends on the question completely. In this case, why would I want to do it? Because 1 over 25 is not reducible. I can't reduce that at all. But I can apply this rule going this way and now break it up like this because check this out. The square root of 1 in the numerator is just 1. Ha. The square root of 25 in the denominator, haha, is just 5. And ladies and gentlemen, there is your final answer for that one. 1/5. So the only way I can do that is by applying this rule. I actually went backwards. In the other example, I actually had to apply the same rule, but I went this way. I took two individual ones and made it bigger. Which one do you have to do? Completely depends on how the question starts. So that's the quotient property. Next one, let's go to the product property. It's similar in idea. It just happens to say now if I have the product of two radicals, similarity is this, the roots are the same. Then that means you can rewrite all of this stuff over the same radical with the root being the same. Notice that doesn't change to an M or a P, it's still the same root. And these bases, even though they're different, that's A and that's B, they can go underneath the radical, just like that. So which way do we have to go? Well, sometimes it's going to be better and more beneficial for you to take it back and rewrite it like this. Sometimes it's going to be beneficial for you to take it and rewrite it from these two individual ones over here. Depends, again, completely on the question. So let's do a couple examples so you see. Let me pull this one up here. That's an easier one. So I had the square root of 7 times the square root of 3. What can I do with that? Well, I cannot reduce the square root of 7 down to anything. I cannot reduce the square root of 3 down to anything, but I can certainly take these things since they have the same root. It's squared and it's squared. I can do those things and rewrite it as the square root of 7 times 3. Awesome. Well, now I can actually take 7 times 3. So that gives me the square root of 21. So can I take 21 and break it up into two things where one's a perfect square? No. So that right there would be my final answer. So what would happen if I have something like that? Let's say I have the square root of, I don't know, 8 times the square root of, I don't know, 2. Simple example. Well, I can't take the square root of 8. There's nothing I can do. I can't take the square root of 2. There's nothing I can do. Nothing I can break it up into. But I can apply this product property and rewrite it as the square root of 8 times 2, which that, check this out, which means I get the square root of 16. Oh, lovely. Which means this whole thing would just be equal to nothing more than 4. So that's applying this rule going that particular way. Okay? Well, let me erase some of this stuff. How do I do that? Let me erase all this jazz. Lovely. And now, let's take an example and apply both the product property and the quotient property. So you're given this thing right here. Oh boy. What do I do with that? Well, I'm going to take 6. Well, boy, what can I do? Well, I can apply this. I can apply the product property to the top two things right here. So I can take and rewrite that in the numerator as the square root, because they both have the same base. And I can take that times 6, or 6 times 30. Lovely. And all of that is going to be then over the square root of 10. Well, let's keep going. So now that I applied in the numerator the product property, I'm going to get the square root of 180. Whoa. Lovely. And all of that is over 10. So now what can I do? Well, I see that I have square root. I'm dividing. So why don't I do this? Why don't I take this whole thing now and make it 180, this is pretty cool, over 10. Why would I do that? Because I can reduce 180 over 10. The zeros cancel out, and what am I left with? The square root of 18, actually let me back that up. Back it up. I'm left with the square root of 18 over 1. That's cool. Well, let's keep on going. I'll come over here, bloop, right down here. So that means I can break this up. Now I'm using, again, the quotient property the other way. I'm breaking up the entire bigger square root into a smaller square root of 18 over the square root of 1. Well, let's keep going. I love it. The square root of 18 is just the square root of, well, we can do something about that shortly, but the square root of 1 is just 1. So technically, this whole thing here would just simplify down to the square root of 18. Okay, am I done? If you want to be incorrect, it's not simplified as much as possible. What can I do? Let's take this 18 and break it up into two smaller square roots. What am I doing? I'm actually taking this product property and going backwards. I'm rewriting it as the product of two individual things. It's pretty cool. So I got to choose wisely though. I want one of these things underneath the radical to be a perfect square. Because I could do 3 and 6. That's a possibility. 3 times 6 gives me 18, but neither of them are a perfect square. So why don't we do this? Let's do 9 and let's do 2. I like that one better. Why, Mr. Molitor? Because that's a perfect square. So now I can finally simplify this. The square root of 9 is a 3. And the square root of 2 is just the square root of 2. There's nothing else I could do with it. So that right there would be your final answer. Cool. I love that question. Let me scroll down and show you something real quick because something that I want to make sure you're clear on. I told you. But if these guys right here, if the roots are not the same, then this rule does not, absolutely does not apply. If you're not sure what I'm talking about, watch this. Let me take the square root of something that you know. The square root of, we'll go 4. We'll take that times the cube root of 8. Well, there you go. What this rule is saying, if it did work, if this not equal sign was there, it would mean then you could do 3 times this 2, because n times m, right here, n times m, will give you the 6th root of whatever a times b is. Well, that would be 4 times 8, which is 32. Well, you can punch in your calculator. The 6th root of 32 gives you a decimal. Over here, you would see this, very simple. The square root of 4 is just 2. The cube root of 8 is also 2. So 2 times 2 will give you 4. So this whole thing technically simplifies, when given to you like this originally, it simplifies to a 4. It's not equal to the 6th root of 32. So that's why I'm just showing you a simple example that if these bases, if the roots are not the same, this rule does not apply. You cannot do that. The roots have to be the same, where you cannot just kind of put them underneath each other and say, game time, we can do it. So there you go. A couple simple examples of product property and the quotient property. But we'll practice these things, of course, in class.